excited. Trig day! We finally get to start trig. Pre-calculus finally starts today. Okay? So today we're doing all about trig. Okay? And then we'll work trig for the longest time. We'll work it into second semester even. It's a good day. Great day. Finally! Trigonometric functions. Alright, so usually in algebra, we'll say, we have a function and we input a number into that function and we get out a number. Okay? In trig, we're going to input an angle and output a number. Okay? So it's a little different. Okay? And so since we're inputting angles here in the trig, we should also talk a little bit about the standard form, if you will, of an angle, okay? Or the standard position, I think would be a better terminology for an angle. So, the standard position of an angle. If I were to draw a crosshair, okay, or a coordinate system, if you will, the first thing that I would put on my angle would be something called the initial ray. Okay? And the initial ray always, in standard position, always goes straight out to the right. Okay? So much so that we call that 0 degrees. Straight out to the right is 0 degrees. Okay? Then, somewhere, wherever my angle stops, this is called the terminal ray. And the angle that is formed here is theta. Okay? And we measure theta from the initial ray to the terminal ray. So we go counterclockwise with our measurement of the angle. Okay? That's the standard position of an angle. Okay? So, let's talk some angles. One of the, whoa, what happened there? There we go. One of the units of measure of an angle is something called a degree. Okay? Now, does anybody know how many degrees are in a complete revolution? 360 degrees to go all the way around a circle. Okay? Or to make one complete, so like I was riding a merry-go-round, 360 degrees gets me one spin. Okay? 360 degrees gets me another spin. Okay? Okay? Anybody know why they chose 360 degrees? That you would think that, but that's not it in this case. At least I don't think so. Anybody know? What's up?
That's how many days it takes for the Orion to revolve around the sun.
Kinda, yeah. It kind of went off of that because it's like 365 days to get all around the sun, and so it's kind of that year-long thing. It's I'm not even gonna try and murder that first word, the sexagesimal counting system. Okay, really, I mean, the real reason that I can think of, and honestly, I don't know. I really don't know why it's 360 degrees. You have to go back and talk to people that developed it way back when to say why it did. But 360 is one of those cool numbers. Okay? Why is it a cool number? Because lots of stuff goes into it evenly. 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, 18, 16 probably does. No, I don't know if 16 does. 20, 24. Lots and lots and lots of numbers go in evenly to it. So we can divide that circle up into lots and lots of different equal pieces, which is one of the cool things. Okay? So let's talk circle. Circle gets the square. Okay? So we said that this was 0 degrees. We also said that 360 degrees gets me all the way around, right? So this would also then be 360 degrees, right? Well, what's halfway around the circle then? How many degrees to go halfway around the circle? 180. Halfway of halfway. What was halfway of halfway? So half of half is 90. Half of half of half. 45. I got no more halves. I can only go 3 halves. So then what's this one? What you got? 135. What's this one? What you got? 225. 225. Straight down. 270. This one. Not just the large group room. 315. Get it, Frank?
You said 312.
Oh, yeah. I said 220. Okay? Now, blow your minds. Ready? So, what's this one then? What's that one? Not, it couldn't be 315, no. But it could be 405 degrees. Right? Think merry-go-round. Okay? If I start, let me start over here on the merry-go-round. Okay? If I start here in the merry-go-round, and I go around the circle, right? And now I stop. Okay? I've gone 360 once, and then 45 more gets me 405. Right? This could also be 765. Now I went around my merry-go-round twice, and a little bit more. Okay. So just because there's only 360 degrees in a circle, doesn't mean that the angle stops there. Okay? We can have ginormous angles. Okay? We could figure out where an angle of 1,280 degrees is. Okay? We can do it. Okay? We just keep going around the circle. All right? So, what I need you to do now is, if you're at the bottom of a page, I need you to start a new page. If you have plenty of space, then you're okay. If you want to start a new page, you can start a new page. But somewhere on your piece of paper, in the middle of your piece of paper, I want you to make a dot. Somewhere on that middle line of your paper, make a dot. Okay? Then, utilizing your straight edge technology, what I would like you to do is I would like you to draw a line segment straight out to the right coming off of your dot. Any length. Go all the way to the edge for now. Then, utilizing Smarty technology, don't eat your Smarties yet. I'll tell you when to eat your Smarties. Okay? But utilizing Smarty technology, what I'd like you to do is I'd like you to pick a certain amount of Smarties to make your radius with. I'll get you guys in just a second. Now what I want you to do is I want you to line up. I'm going to go over here to the computer and do it because it's easier. I want you to line up your Smarties starting with one edge at your dot, and then I want the Smarties to be touching all the way out. So however many Smarties you went with, that's how many Smarties you're going to go with. I'm going to go with 7 because I got 7 Smarties on my board. Okay, so we got Smarties out there. Then what you need to do is you need to make yourself a little tick mark out there and say, well, that's how far out my Smarties go. Okay. Then, utilizing your compass, pointy end goes at the dot. Pencil end goes out at the tick mark. Draw yourself a circle. I'm almost out of the H2O. So what I would like you to do is I would like you to write inside your circle that what your radius is. So my radius is 7 Smarties. Because now what you're going to do is, if I made a tick mark here at this line, okay, so now on my circle, what I'm going to do is I am going to take my Smarties and I'm going to line them up on the edge of my circle. Again, edge to edge, Smarty to Smarty. Then what I'm going to do is I am going to make a tick mark there, and then repeat that process all the way around the circle. So now I would move my Smarties to this side. Whoa. And then I put a tick mark. Okay? Go all the way around your circle. So, you should have gotten all the way around the circle, right? And it should have been, so there should have been, you should have one tick mark there, and then another one there, and then another one there, and then another one down in, oh, let me get rid of this. And then another one down in there, and then another one down in here, and then another one like right there. Right? So it shouldn't have gone all the way around. Okay? And then you should be able to measure this other distance in Smarties. So mine would have been, had I would have done this, had I would have, coulda, woulda, shoulda, had I woulda, would have been like right in here, and I would have had 2 Smarties left over. Okay? So, because my radius was 7 Smarties, for some reason it wasn't working out, but I know what it should be. Okay? And then, so that left me over with 2 Smarties. We'll go in blue. So that's like a 2/7 remainder, right? Right? Anybody with a calculator, what is 2 divided by 7? 2.85714 repeating, you said? So we'll go up to there. We'll go up to there. Yeah? So I went 6 times. So I went 6.285714 sets of 7 Smarties. Right? So I went that far around the circle. Oops. That should be red or blue. Oh, now I'm just going to erase the whole thing. .28. Where have I seen that before? What? 6.28. Where have I seen that before? It's like 2 times pi, right? Okay. So what we've just created is we've just created how to figure out what something called a radian is. Okay? A radian, 1 radian, is the measure of the central angle theta that intercepts an arc S equal in length to the radius r of the circle. So if I get my compass back out here and I extend it out there, the radian, the angle R is going to be, oops. Now I need to get rid of that. Oh, can I get rid of, I'll just go put it somewhere. Hey, whoa. There we go. Okay. So if I were to extend a line right here, this angle in here, which we will call theta. Okay, theta is a name for an angle that we use a lot in the trig. Theta is long enough that this purple arc length, which we'll call S, okay, S here is equal in length to my radius. So if it took us, so approximately how many degrees do you think is 1 radian? A little over 50? Guessing? Okay. Maybe 50? Well, let's figure this out. Okay? So if it took us 360 degrees to get around the circle, right? And you guys said that, because our 6.28, you guys said that was 2 pi, right? And those were radii, right? 2 pi radii to get around. So if I wanted to find the degree measure, I would take 360 and I would divide it by 2 pi. Somebody with a calculator, what is 360 divided by 2 pi? 57.29, so we'll call it like 57.3. So theta in degrees is 57.3. Theta in radians is 1. Okay? So my red angle here, my red theta here, theta is equal to 57.3 degrees. Theta is equal to 1 radian. And for radian, it's kind of like the degree symbol, but we use a little bit of a lowercase r.
Is that every situation or just
Every situation. 1 radian is approximately 57.3 degrees. How many radians does it take to complete 1 revolution? Well, it takes 2 pi radians to go all the way around a circle. Okay? So if it takes 2 pi radians to go around the circle, that is also 360 degrees. Okay. Though that would be a fraction that's equal to 1, correct? 2 pi radians over 360 degrees is a fraction equal to 1. Likewise, 360 degrees divided by 2 pi radians is also a fraction equal to 1. If I reduce those, I get our conversions pi over 180 degrees, or excuse me, pi radians over 180 degrees, or 180 degrees over pi radians. And we'll use those tomorrow when we convert degrees to radians and radians to degrees. Those are your conversions. Okay? We use the, what's it called? Factor label method, where you kind of do it in science, and you convert using labels and stuff, and you cross out labels and all that good stuff. Okay? I think that's a good spot to take a pause for the cause. Oops.